Okay, Wildcats, today we're at journal page 80, special right triangles. All right, now let's look at this right triangle with respect to the trig functions, okay? So sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Now cosecant is hypotenuse over opposite, secant of theta is hypotenuse over adjacent, and cotangent of theta is adjacent over opposite. We would update that portion of the notes. Excuse me. All right, now let's take a look at the 30, 60, 90 triangle. Okay, now the angle 30 corresponds to x, the 60 corresponds to x squared to 3, and 90 corresponds to 2x. Now let's look at the 45, 45, 90 triangle. Okay, 45 corresponds to x, 45 corresponds to x, and 90 corresponds to x squared to 2. You would update your notes. Okay, now your notes are updated. Let's take a look at the examples. All right, find the values of sine, cosine, and tangent function. Now, sine of theta is opposite over the hypotenuse, okay? Now, we don't have the hypotenuse, so we need to find it, okay? And we're going to use a squared plus b squared equals c squared, or in this case, opposite squared plus adjacent squared equals hypotenuse squared, okay? So let's use our work. I guess we can use space up here probably. Okay, so 15 squared plus 36 squared equals h squared. Okay, so to find h, we take the square roots of both sides. So h equals the square root of 15 squared plus 36 squared. So let's use our calculator to get that. Okay, so control square root of 15 squared plus 36 squared is 39. So the hypotenuse is 39. Okay, so the hypotenuse equals 39. So now we know that sine is opposite over hypotenuse. So that's 15 divided by 39. Okay, well 15 divided by 39 reduces to be 5/13. All right, now let's take a look at cosine of theta. Okay, cosine of theta is adjacent over hypotenuse. So that's adjacent over hypotenuse, which is 36 divided by 39. Okay, which you always want to reduce, which 36 divided by 39 reduces to be 12 divided by 13. Okay, tangent of theta is adjacent over hypotenuse. So that's adjacent over opposite, which is, well, wait a second. That's not right. And this is why you want to have your notes just to double check. And this can happen, and that's why you want to double check. I put adjacent over opposite, but it's opposite over adjacent. So you always want to use your notes just to make sure that you're correctly. Okay. Also, this might be a good time to introduce saw. Notice opposite over hypotenuse, ca, adjacent over hypotenuse, and toa, opposite over adjacent. Okay. All right. So opposite is 15 over adjacent is 36, which reduces to be 5/12. All right, now let's take a look at example 2. Okay, so we know sine of theta is opposite over hypotenuse, and we want to double check. So opposite over hypotenuse, so we're good. Now, we have opposite and we have hypotenuse, so that's 16 divided by 34, which reduces to be 8/17. Okay, now cosine is adjacent over hypotenuse. We don't have the adjacent, so we need to use a squared plus b squared equals c squared to find the adjacent. So we know that the adjacent squared, let's call it a squared plus opposite 16 squared equals hypotenuse squared 34 squared. Okay. Now, to solve for a, we're going to subtract 16 squared from both sides and take the square root. So a equals the square root of 34 squared minus 16 squared. Okay, so let's use our calculator for that. So control square root of 34 squared minus 16 squared is 30. So the adjacent is 30. Okay, so now we have 30 divided by 34, which reduces to be 15 divided by 17. Okay, now tangent is, and again we check here, TOA, so that's opposite over adjacent. Okay, so then that's 16 divided by 30, which reduces to be 9, 15. Okay, go and finish up example 1 and 2. All right, now let's take a look at example 3. Use trigonometric functions to find the missing values. Okay, so here in example 3, we have a 30, 60, 90 triangle. And going from our notes, we know that in our table, 30, 60, 90 is x squared is 3, and 2x. So basically what we need to do is find x. Once we find x, then we can fill in the table and we'll know all the corresponding sides. Now we're given that the hypotenuse is 74. That helps because we know that that's 2x. So we know that 2x equals 74. Well, if we solve for x, we divide both sides by 2. X equals 74 divided by 2 is 37. So x is 37. So now we know x, we know that this is 37. This is 37, square roots of 3. And we knew that 90 across was 74. Okay. And so x is 37. And now y is the across from the 60, so y is 37 square roots of 3. All right, let's take a look at example 4. Okay, so again, if this is 60, we know this is 30, so this is a 30, 60, 90 triangle. Okay, now we need to use that we know that this is x square roots of 3, and 2x. Again, once we find x, then we know the table. Okay, so it looks like 10 is across from 60, so we can set x square roots of 3 equal to 10, and we're going to solve for x. Okay, so we divide square root of 3 by both sides, so you get x equals 10 divided by square root of 3. Now, you never leave a square root in the denominator, so what we need to do is we need to multiply this by square root of 3 divided by square root of 3. Well, then that becomes 10 square roots of 3 divided by the square root of 3 times the square root of 3 is 3. And the reason, let me show you a calculator, the reason why that is. All right, so if we do control square root of 3 times control square root of 3, we get 3. And the reason being is the square root of 3 is 3 to the 1 divided by 2 times 3 to the 1 divided by 2, which 1/2 plus 1/2 is 1, so that equals 3 to the 1 power. Now it says false, and so you have to be careful with that, but I'll show you if we did this 3 to the 1 divided by 2 times 3 to the 1 divided by 2, it says 3, and if we do 3 to the 1 is 3. So you want to be careful using the equal sign and true or false, because sometimes it will say false, but really it's true. You see that these are equivalent. So basically that's why you get 3. Okay. All right, so now we know that this is 10 square roots of 3 divided by 3. Okay. Oh, wait a second. Sorry. Whoa. Across from 60 is 10. What am I doing there? That's 10. Okay. Now, the x value is the 10 square roots of 3 divided by 3. And then across from 90, well, if we know x is 10 square roots of 3 divided by 3, we just multiply this by 2. So this is 20 square roots of 3 divided by 3. So you can see from our mistake here that you want to be careful when you plug the numbers back in. The mistake I made was I put this value for here, but then when you double check, you see that 60 is across from 10, and this is 10, not 10 square roots of 3. Okay. Now the x value, well, that's across from 30, so that's 10 square roots of 3 divided by 3. Now the y value is across from 90, that's this value, so that's 20 square root of 3 divided by 3. All right, example 5. All right, so it's a 45, 45, 90. So we know here that this is x squared to 2. All right, so we look what we have. Well, here we have a 90, that's 7 squared to 2, so we know that this is 7 squared to 2. That tells us that x is 7. And if this is 7, this is 7. So both x and y values are 7 and 7. All right, go ahead and finish up example 4 and 5. All right, example 6. Okay, so again, we know 45, 45, 90. So this is x squared to 2. Now here we see that across from 45 is 3 squared to 2. That means the x is 3 squared to 2. Okay, well, if that's 3 squared to 2, this is 3 squared to 2. Okay, so the x value we know is 3 squared to 2. Now, if the x is 3 squared to 2, we need to multiply this times square root of 2. So this is 3 square root of 2 times square root of 2. But we know that the square root of 2 times square root of 2 is 2. 2 times 3 is, so this equals 6. So your y value is 6. All right, go ahead and finish up examples 3, 4, 5, and 6. All right. Find the 6 trigonometric functions for theta. Okay. So we know that sine of theta is opposite of our hypotenuse. We don't have that hypotenuse, so we need to find that. Okay. But we can use diagram theorem. So let's use, guess probably, not much space. We can probably use this space right here. So we know that h squared equals 24 squared plus 70 squared. Okay. Well, to solve for h, we take the square root. So h equals the square root of 24 squared plus 70 squared. So let's use our calculator. So control square root 24 squared plus 70 squared is 74. So your h value is 74. Okay, so if h is 74, then sine is opposite over hypotenuse. So opposite is 24 divided by 74, which reduces to be 12 divided by 37. Okay, now cosine is adjacent over hypotenuse, so that's adjacent over hypotenuse, which is 70 divided by 74, which reduces to be 35 divided by 37. Okay, now tangent is opposite over adjacent. Well, opposite is 24, adjacent 70, so that's 24 divided by 70, which reduces to be 12 divided by 35. Now, cosecant simple, you just switch its hypotenuse over opposite, so that's 37 divided by 12. Secant is hypotenuse over adjacent, so that's 37 divided by 35. And then cotangent is adjacent over opposite, so that's 35 divided by 12. Go ahead and finish up example 7. Example 8. So we know sine is opposite over hypotenuse. Well, we don't have opposite, but we have the hypotenuse. So we need to find that. So let's just call this x. Okay, so we know to find x, it's x squared plus 9 squared equals 12 squared. Okay, well, x, we know subtract 9 squared, take the square root. So x equals the square root of 12 squared minus 9 squared, which, let's use our calculator. Control square root of 12 squared minus 9 squared is, now you get a decimal, we don't want a decimal, okay? So we're going to leave it as a square root. So we're going to do 12 squared plus 9 squared is 60, not plus, sorry. 12 squared minus 9 squared is 63. Okay, so that equals the square root of 63. We're going to leave it as the square root. Okay. All right. So sine is opposite, so that's the square root of 63. Over hypotenuse, which is 12. Okay, now cosine is adjacent, so that would be 9 divided by 12, which reduces to be 3/4. Okay, and then tangent is opposite over adjacent. Opposite is square root of 63, and adjacent is 9. Okay, now cosecant is hypotenuse over opposite, so that would be 12 divided by square root of 63. But you can't leave the square root of 63 in the denominator, so we need to multiply top by square root of 63, square root of 63, which I guess we've run out of space. We'll come over here. Okay, so that's 12 square root of 63 divided by 63. Okay, now secant. Secant is hypotenuse over adjacent. Well, that's easy. That's just 4 divided by 3. Okay, now cotangent is adjacent over opposite, so that would be 9 over the square root of 63. But remember, you can't leave the square root of 63 in the denominator, so we need to multiply by the square root of 63, square root of 63. And then I guess we'll just have to come down here. Then that becomes 9 square roots of 63 divided by 63. And I believe that reduces to the square root of 63 divided by 7. Which makes me think if this reduces, we need to double check to see if this reduces. And you can see here from the calculator work that 9 divided by 63 reduces to be 1/7. 12 divided by 63 reduces to be 4/21. So this becomes 4 squared is 63 divided by 21. So you always want to make sure and see if you can reduce. Okay? All right. Now, last example, example 9. Okay? So sine is opposite over hypotenuse. So that's opposite over hypotenuse, which would be 21 divided by 35. Okay, cosine is adjacent over hypotenuse. Okay, so basically let's just call this A. Okay, so now we need to find A. And we know that A squared plus 21 squared equals 35 squared. Well, to find A, we subtract 21 squared and take the square root. So A equals the square root of 35 squared minus 21 squared, which equals, let's use our calculator for that. Okay. So control square root of 35 squared minus 21 squared is 28. Okay. So that means this is 28 divided by 35. All right. Now, tangent, opposite over adjacent. So opposite's 21 divided by adjacent is 28. Now, let's just double check to make sure these don't reduce. So let's do control divide 21 divided by 35. So that reduces to be 3/5. So now control divide 28 divided by 35 is 4/5. And then 21 divided by 28 is 3/4. So again, you always want to double check to make sure if they can reduce, they need to be reduced. Okay. Well, cosecant's easy. That's hypotenuse over opposite. So that's 5 divided by 3. This is hypotenuse divided by adjacent, which is 5 divided by 4. And then this is adjacent over opposite, which is 4 divided by 3. All right, go ahead and mark out example 10 and go ahead and get started on your assignment. And have a wonderful Wildcat day.